No, x, the only part that you use 0.4 is in the probability applet to get the z-score.
Right. And then after that, we have to solve for
and then
x,
it's x
right?
minus the mean.
Okay.
Yeah, so you're solving for x, so it's x minus 10 over 5.
5. So times 5. Oh, I get it. 0.253 times 5 equals x minus 10 and then plus 10. Okay. That's cool. Good. We put in 40% in the output. Okay, good. All right.
So do you get it now?
Yeah, I get it. I'm just going to punch it into the calculator and make sure I got the right answer. 0.253. 11.265.
Did you do the negative 0.253?
Yeah,
That's what it is.
Thank you. 0.253 times 5 plus 4.735. Yay. Thank you, Ashley. That was perfect.
Yes.
Wow. Awesome. Okay.
Well,
Shoot.
Derek hasn't written back. When we talked earlier, he said he was the one who said 9:30 his time, 8:30 our time. So I said, okay.
Okay.
And I don't really want to wait too much longer, and I can't do it tomorrow.
Yeah, we have to. It's due.
So I feel bad, but.
Well, maybe we'll just start without him and see if he texts while we're doing it. He can jump in the last part.
Yeah.
Around. Yeah, I'm fine with that.
I texted him and I said, hey, we're going to start soon. So
good.
Let's just go for it.
Okay. That was the only thing I had on the homework. So want to just jump into the test?
Yeah. Yeah, that was the only one I had on the homework. So.
Find test.
Really good. Good hunt. All right, well.
Oh, is it lesson 7?
Yeah.
Nice.
Okay.
Absolutely.
Oh, wait, are you recording?
Yeah.
Oh, good. Okay.
Yeah, I am. So we are ready.
Okay. True. And participate. Yep. True. Okay.
Yep.
And use the normal probability to find the combined area under the standard normal curve that is to the right of z=1.358 negative.
So I got 0.8255. So we're shading the area in between the z-scores.
No, I think it's to the right of the positive and to the left of the negative. So we want both of those two little ones, right?
But it says the combined area.
Right, so if you click on one of them, it's 0.0872. you both put it in blue, it's 0.1745,
Oh, I think you're right.
I have it on film.
which will be 175.
It's confusing when they say combined to me.
I know, it is.
When I think of combined, I think of, oh, they're overlapping.
I know.
So 0.175 then?
Yeah. That's what
We're
I
going
said.
to the third.
Third decimal.
Okay.
Okay, which of the following will have a similar standard deviation if 9 observations are randomly drawn from the population? Oh my gosh, I hate this.
Oh, what?
Okay, standard deviation, if you have 9, and the distribution of individual observations, no. The distribution of the sample means yes. I think it's either sample means or cannot be determined, but I think it's going to be the sample means because we'll have a smaller standard deviation. Oh, I didn't realize that. I thought it said similar. We should have a smaller standard deviation. Okay.
If 9 observations are randomly drawn.
The distribution of individual or, the standard deviation gets smaller when you do a larger size. So I think the individual ones, yeah, I still think it's B.
Yeah.
Okay.
You think it's B, the sample means?
Yeah. Because if you have individual observations, standard deviation
okay. Yeah.
is larger. It deviates more. But the sample means yes. Okay.
That's a confusing question.
It is.
That wasn't on our homework.
They read them to confuse us.
Okay, which of the following results implies that the spread in, I always forget what that means. X decreases as the sample size increases. Which of the following results implies that the spread in the mean decreases as the sample size increases?
It's gonna be the spread decreases as the sample size increases. I think that one is the law of large numbers. I think. Let me pull up my notes from the last. Okay. It says.
Okay. Yeah, it's the law of large numbers.
What is?
The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. Is that what it's asking?
Yes.
Okay.
Yes. Okay. Save. So that's our information. Diane earned a score of 160 on a quantitative portion of the GRE. What's the Z-score? Corresponds to Diane's score. Okay, Z-score. Value. Minus mean.
And I just
Okay. Mm. 160. 150.8. 8.8. Diane's score. Mean of 150.8. Standard deviation of 8.8. What's the number? value?
So I got 1.045.
X minus mean over standard deviation. Hold on. You don't have to do the square root.
Not on this one, no.
Okay, that's throwing me off. Okay, can you just punch it in? Hang on a second. One point oh 0.04545. This is the Z-score. 1.045. Okay, what did you get?
I got 1.045.
Oh, good.
Yes.
Okay. What's the probability that a randomly selected student will score above 160 on the quantitative portion? Okay. So that's
So
above 160, so we have to put that into the 1.045 in the Z-score. And it's
we'll score above 160. Okay.
so it's 0.148.
Yep. Yeah, that's what I got.
Good.
Look at us, we're getting it.
I know, that's awesome. And a random sample of 5 students was selected to take the GRE. Here are their scores. What's the Z-score corresponding sample mean of these students' scores? Okay, let's just figure out the mean. Okay.
Oh, okay. So did you get a mean of 160?
Yeah.
Okay. So now what do we do exactly?
So 160. What is the Z-score?
We have to find the standard deviation.
Sample mean. Oh gosh. Should we put it into that little other thing? SPSS. I'm trying to find that. And it'll tell us all things. Okay. Hang on.
I wish I had a sheet that just told me all of the formulas.
I know.
I actually wanted to make one. We just haven't had time.
Yeah, we might need that later.
It just gets confusing, like when you add like just one more step, and so you're like, wait.
I know. It's too good. Let's see. How do we do this? Analyze. Oh, graph? No.
Okay, I'm trying to find in my notes the standard deviation. Okay, so this standard deviation. Oh yeah, that's the variable minus the mean is the standard deviation.
Variable. What's variable?
So the variable would be like for each one.
Oh,
yeah, remember when they had those like tables?
Yeah. So how do I figure it out with this thing?
Okay. So is it 160, 175?
Oh, I got it. I put it in the SPSS. The mean is 160. The standard deviation is 10.05, so we could just say 10. And we need to do each one, right?
Well, I can't tell because if we do each one, though, there's only one box. So what is the z-score corresponding to the sample mean of these student scores? So we just need to find a z-score. I'm guessing it would be the same.
What do we use for x then? Oh, what about, oh shoot. What about on here? I could find the z-score maybe using this SPSS. I don't remember how to do that. Descriptive statistics.
Well, what was the standard deviation? Is 10 point what?
10.0.
Oh, so it's 10.
Yeah. Okay. So I have the, what are we looking for? Z-score?
Yeah.
I thought that was on one of these.
I'm seeing what's. Oh, it doesn't make any sense.
Okay, options.
Oh, wait a second. Okay, this is still. What is the z-score corresponding to the sample mean of these students' scores? So this is still a part of the scores on the quantitative portion of the GRE are approximately normally distributed with the mean of 150.8 and a standard deviation of 8.8. So I'm wondering if, no.
We still need the number to get the z-score.
But wouldn't the standard deviation be 8.8?
I don't know. When I punched it all in here, it said 10. It's in that SPSS.
I know, I'm just saying because they gave us this information up top, and this is for the it says this information is for the next 4 questions.
Oh.
Yeah, it says use the following information to answer the next 4 questions. That's confusing.
Yeah, that's
Okay.
So Their scores
If it's
are
160, then it's
this is z-score corresponding to the sample mean of these students' scores. So we use these scores for the sample mean, right? Which is 160. Oh my gosh.
but is it 160 minus 150.8 over 8.8, or are we supposed to use one of those scores? I'm so confused.
Well, that's just what we did on number 7. That was the whole thing. Because it was 160.
Well, I know, but the mean is 160, the sample mean. And I was taking what the up top, just the normally distributed with mean 150.8 and a standard deviation of 8.8.
Mm-hmm. So then that one is 9.2, and then we punch it in, or we just use the z-score. Oh, that was the probability. Yeah, so it is 9.2, right?
What's 9.2?
Is that the z-score?
I feel like that seems high.
Oh yeah, it can't be 9. It can't be more than 4. Oh yeah. I don't know. I'm really lost on that one. Random sample of 5 students with z-score corresponding to sample mean of these scores. Measure answer z-score.
Let me see. It's I mean, I'm guessing that we're just punching in 160, which is the sample mean, as the variable, and then doing 1 minus 150.8 over 8.8. I know it's the same as above, but that's happened to us before.
Right. But that one on 7, it wanted the probability. So how do we get the z-score?
Well, I know we did the z-score on number 6.
So we had,
So what I'm saying on the equation for z-score, z equals x is the variable minus the mean over the standard deviation. And I'm saying that the variable will be 160, which is the sample mean that we took.
yeah, so then it's the same as number 6,
Yeah.
1.045.
I guess
Right.
I don't know. I don't understand how what else it would be.
I don't either.
So weird.
Okay, we'll just
Let me
do
see if
that.
there's anything on the homework.
Okay.
No, because those all give sample sizes.
Oh, it's 5.
What?
It's 5.
Oh.
Oh my gosh.
Oh, that's right. The sample size is 5. You're right. That's it. You figured it out.
Okay, z equals, so is that 5, the first one, minus, no, it's 160. Okay, 160 minus
No, it should be 5 minus 160.
I think 5 is the, oh,
Okay, wait. No.
square root number.
Hold on. Okay, so then,
But which
oh my
standard
gosh, this
deviation
is
do
so
we use?
confusing.
Is it
So,
8.8 or is it 10? Probably 8.8.
I would do 8.8 because that's
Yeah.
what we were given. So wait, what is it? What's on top?
I think it's 160. Wait a minute.
minus
No.
150.8?
I don't know.
Oh my gosh.
I'm confused again. Sample mean is 150, is 160. Right? Yes. So it's not 150.8 for this one.
Yeah, but then what's X? That's what I'm trying to figure out.
If we're using a new sample mean for these 5, then we're not using the one up there before number 6. Oh, mean and the sample mean are the same, right? 150.8. Except no, that's not more than 30. Oh my gosh.
Because I don't know what X is, the variable. Because if the sample mean,
Yeah. Let's see.
oh man.
6. Let's pull up the homework. Lesson 5. Okay.
And there's nothing like this in our homework, so that's not cool.
Mm-hmm.
Okay.
Maybe, okay. Maybe we just have to look at the bell and use the 68, 95, 99. That doesn't make sense either because this is what this is for. Okay, B square is 5. Maybe it's 5. 5 minus the mean 1 over the standard deviation, which was 8.8. That is totally wrong. That's it.
Yeah.
Okay.
This doesn't make any sense.
-17, that's not a z-score.
No, I know. So,
I don't know, I think we should just probably just guess, but that's going to be wrong because you have to put in a number to 3 decimals.
yeah, if we guess, we're definitely getting it wrong.
And on the quiz, I lost it. Okay, a random sample of 5 students was selected to take the area their scores on.
Okay. I remember because this is the formula. That's right. For sample means the formula for the z-score is the value minus the mean
over
the standard deviation.
Yeah, but we don't have all that.
It's the mean. It's 150.8 minus 160, or it's maybe it's 160.8. minus,
How?
because it's the x with the bar on top minus the u
Uh-huh.
over the standard deviation divided by the what is it? The square root of
Square
n.
root of n. Yeah, but on this number 8, it just says 5 students. So I don't see how we...
I know, and that's the sample size, so that's n. So
There's
on the
5.
bottom, it's going to be 8.8 over the square root of 5.
Okay. And on the top, it's 160
And then
minus 150.8.
I'm trying to remember, what does it say up top?
Value.
So u is 150.8. So yeah, it's 160 minus 150.8.
So we're just using
And
the
then that
5.
should give us the z-score.
Okay, let me try that. 160 minus 150.8. 9.2 is on the top.
Yeah.
And
Square root of 5 is 2.236.
2.93, 5, 4, 7, 9. And we're going to say 9.2 divided by 2.3.
So I got 2.337.
Yeah, 2.337. Okay. But is that the z-score?
Yeah, because that's what the formula is for.
So not the probability. Okay, yes. 2.338 is the z-score. How? That's weird. 160, 175, 168, 149, 53. Okay. Let's go with it. I'm good. Okay,
I
9.
think that's right because that's what the formula is.
So
So
we're just using the 5 as the number. Okay, so the next one, what's the probability that 5 randomly selected students,
we'll have a mean score that is greater than the mean achieved by the students of the previous problem. So we should just be able to put the z-score into the normal probability applet and shade to the right, and it'll give us a really small percentage.
Okay, it's 0.0097.
Yeah.
So it's 0.010.
What?
To round to 3 places.
Oh, this one is, it's not saying, it's saying to round to 4 decimal places. So just put 0.0097.
I didn't even read that. 0.097. Okay, good. So,
Okay.
oh my gosh. Okay.
I know.
It hurts my brain. Supposed to mean GPA of BYU students is 3.5. Oh, that's good. Oh, shoot. Let's do 3.5, and the standard deviation is 0.7.
Random sample of 81 students will be drawn.
Good. So it doesn't matter that it's left skewed. Because it's 81 students, it will be normal.
Approximately normal.
11. What is the mean
Okay.
distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Okay. Mean. What is the mean? Do I do it backwards?
Suppose the mean is 3.5. Oh, man.
It's the same thing. The mean is the same, 3.5, right? The only thing that would change is the standard deviation. 3.5.
Yeah.
Okay. Okay. We have 4 more.
This one's hard. I know. We're almost done. What is the standard deviation of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population?
Okay.
What is the standard deviation? Well, isn't it just the 0.7?
No. We need to get the week. Let me pull up my other notes because this is going to be crazy.
This doesn't make any sense. I don't remember doing this on the homework or on the preparation.
No, not this time. It was maybe number 6. Do I have that one open? No, I have 5 open. Oh. V equals x minus mean over standard deviation. This is 5. So it's 6. I do need to open 6. This is 6 says oh. 6 and mark. Okay. Hang on a second.
What formula are we supposed to be using for this?
I don't know. That's what I'm going to try and find out. Okay. Oh, I think I just got it. Hold on. Okay. The mean of the sample mean is U. Standard deviation of the sample mean is standard deviation over square root of n. That's the one.
You're right, that's what it is. Standard deviation or.
Okay, so standard deviation, we're going to come up 0.7 over 81. Square root of 81 is 9. So 0.7 7 divided by 9. Okay, so it's 0.0777. Is that what you got?
Yeah. So we're doing 3 decimal places on that one.
Decimal places. So I put, oh shoot, I just make it an 8. So I put 0.078.
Okay.
Is that right?
Yeah.
Oh my gosh.
I know.
This is crazy.
Okay.
Probability. 81 students will be less than 3.3. Okay. You need the z-score? Yes. 2.3 minus the mean. Let's see what this means. Three. 0.5 over 0.7 over square root of 81, right? Equals -0.2.
Okay. So 9.
2.5716. And then we put that in for the z-score. And the question is,
So we're finding the probability.
the probability that the mean for this would be less than 3.3. So we need the less than.
Everything to the left
Yeah.
of the
So
z-scores.
I have 0.9949.
Yeah.
0.995. Right?
Yep. Yep, that's right. Okay, we're almost done.
Yeah.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? Okay, so now we're just shading to the right.
Mm-hmm. Greater.
That's nice. That's easy.
The rest of it. So it's
0.005.
Good.
Did you get 0.005?
Okay. Yeah, I did.
Okay. Okay.
Okay, the Coast Guard assumes the mean weight of passengers in commercial buses is 185. The previous value was lower, but raised after a tragic wedding accident. Standard deviation is 26.7. The weights of a random sample of 48 boat.
Commercial passengers sample mean. Oh, sweet. They give us like everything.
Yeah. And the probability with a random sample will have a rate that is as extreme or more extreme, either above or below the mean, and was observed in this sample. What?
Okay, so we're using the z-score for sample mean and then plugging it into the normal probability output. And we have to And
Okay, wait, look at that note. What are they talking about here? As extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean as ours in the positive direction. What?
so I think are just shading to the right. I don't know what else that could mean.
Okay, let's plug them all in. So we have the value. Wait. Oh,
What is it? It's
185.
now I can't remember. What is it? Is it 177.6 minus 185? Or 185 minus 177.6?
It's 177 first.
Okay.
Well, hold on, wait. The mean or the sample mean?
Oh, it's a sample mean first. And then, so it's 177.6 minus 185.
Okay. Standard deviation is 26.7, and that's over the square root of 48. Okay.
I like it better when the square roots are
Yeah.
easy numbers.
And that is 77. Negative 7.4. Okay. I got negative 1.92.
Wait, what'd you get as the z-score?
Negative 1.920.
Okay, how did I get a positive?
Well, if we did 177.6 minus
Now I got a negative. I don't know why it did a positive. Well, it's, I mean, we have the same z-score, so.
right, these
Then we want, so find the probability that a random sample of passengers will have a weight that is as extreme or more, either above or below the mean, and was observed in the sample below. This extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as that doesn't make any sense.
I think it's trying to say we're using both sides of the applet, both of the teeniest. Because when you think about it like that, and then you do it again, it's saying far away in the positive direction too. So I think it's both of them.
So then is it 0.055?
Yes. Okay, I'm going to submit it.
Okay.
Yeah. So far, so good. Oh my gosh. Oh, and it's 13 and 14.
Dang it.
But that's it. Shoot, those we thought we had right on the money too. We weren't even agonizing over them so much.
I know we weren't, and I really don't know. I don't know what went wrong with him.
I don't
Okay, so
know.
what
I
is the
got
probability?
88%. Let me write down my other answers. Yeah, you can figure it out. Zero.
Okay, so let's see. N equals 81.
Wow, I can't believe we got that number 8 right. I mean, I'm loving that we did.
Which one was number 8 again? Was that the one we really struggled
Crazy
on?
one. Yeah. Oh. On one of mine, it says view feedback. I'm going to click that in a second.
What? It's...
Okay.
What was this one? What was the probability that the mean GPA for randomly selected students will be less?
Okay.
I mean, is 13, then were we only supposed to shade to the left of negative 2.571? Because that's what the z-score is.
Well, let me jump back into the quiz and so I can see the question again. I'll go back 1.7. Start quiz. Okay. 13. What's the probability that the
I
mean
think we did that wrong. Yeah.
probability mean GPA will be less than 3.3? Okay. 3.3.
I think we had those switched.
So it wasn't supposed to be 3.3 minus 3.5?
No. It's 3.3 minus 3.5. I'm talking about the answers for 13 and 14. I think they're supposed to be swapped.
Oh, yeah.
Because the z-score for 13 is negative 2.571. When you put it in the applet down there,
Yeah.
we shaded to the right, and that one was asking what is the probability that the mean of students will be less than 3.3? So wouldn't it be less than the z-score negative 2.571?
So
Which would be
should have been 0.005.
0. Yeah. Because then 14 is what is the probability that the mean GPA for 81 randomly selected Idaho students would be greater than 3.3?
I think you're right.
Okay, I'm going to submit it now and see.
Okay. Yeah, try those. I'm going to redo mine.
Yes, that was it.
Good. Okay. Let me punch my
Okay, let me know which ones you need me to tell you. I don't know what happened to Derek.
I know. That's kind of sad that he missed this quiz because it's good to bounce the ideas off of somebody.
I know.
Large numbers.
Do you want me to go through and tell you the answers?
4, 5. I wrote them all down just when I get to the 13. 1, 4, 8. When I did it last time, I just was going really fast and I made
Yeah.
transpose the numbers. 3, 8. So if I'm saying something that's wrong, just tell me. So 9, I'm putting 0.0097.
Yeah.
And 10 is normal. And 11 is 3.5. And 12 is 0.078. Okay, so 13 is 0.005.
Yep.
14, I'm switching for 0.995.
I don't know how we mixed that up.
Funny, I know that we just switched it. And 15, 0.055.
Yeah.
Okay. Submit, yes, please submit, and good, 100%.
Awesome.
Awesome.
All right, good job.
Yeah, go us. Okay, cool.
We're figuring it out. Okay. Well,
Awesome.
I guess we can text with Derek to figure out a time for Monday.
Yeah.
Let's just plan on Monday night around 7:30 or 8:30, and then we
Yeah,
can lock it down with Derek.
Right, same thing. Sounds good. Because that's our usual.
Okay.
Okay.
Yep. And I'll put this on the discussion board and post it for us. So
Good. Thanks for doing that.
all right. Well, have a good weekend.
Yeah, you too. Thanks, Ashley. Bye.
Yep. Bye.